Okay, in this video, we're going to talk about applications of the graphs of sine and cosine functions called sinusoidal graphs. It's essential that you understand the previous section, section 5.5, where we talked about how to find the equations of graphs, because this is just applications of the same idea. In this first problem, we've got this spring. We attach the mass to it. Here, what we do is we actually pull the mass down 4 feet below the equilibrium position and then let go. So what you end up with is what's called harmonic motion. The ball goes back and forth. Notice at t equals 0 is when you let go of it. So the graph, if you were to graph this situation, it would look kind of like this. At t equals 0, the ball's negative 4 feet below. And then since it takes 2 seconds to complete one cycle, at t equal 2 seconds, it's also negative 4 feet below. Anyway, so when you have to decide whether to use a sine or cosine graph, you should ask yourself, where do you start? In this case, since you pulled it down, you would start at the extreme point. In this case, it would be the minimum. So a cosine function is what you would use here. Notice there's no vertical shift. The period is 2 seconds, so period would equal 2 pi over b. So that implies b is pi seconds. The amplitude is 4, but notice it starts off below, so a would be negative 4. And then, so there's your equation. The distance from the equilibrium position is negative 4 cosine pi t. This is an interesting question. It says, at what 2 times within the first cycle is the spring 2 feet below the equilibrium position? So again, if you sketch the graph, you get this. Here's my graph. And so what I'm asking is, at what times is the ball 2 feet below the equilibrium position? So this would be negative 2 then. So you could just set the equation equal to negative 2. You could solve it graphically, I imagine, using your graphing calculator. But you could also set the equation equal to negative 2, divide by negative 4. Now when you take the inverse cosine of both sides, remember the inverse cosine of 1/2 will give you the number between 0 and pi. So it's going to give you this value, pi over 3. And when you solve for t, you get t equals 1/3 seconds. See? Now, there's another time too. If you use symmetry, from here to here is 1/3 second, right? The whole distance is 2 seconds, right? From here to here is 2 seconds. So this distance equals this distance. So if you take 2 seconds and you subtract this little distance, which is 1/3, you get the other time, which is 5/3 seconds. So those are your 2 times. Cosine. Let's take a look at this one. Let's see. A pendulum is swinging. Now the pendulum is at this vertical position, and then let's suppose it's swinging to the right. So at t equals 0, we're going to assume that it's at the vertical position, and it's swinging to the right. Now the furthest it goes is a distance of 12 inches away from the equilibrium position. Okay. And it completes one cycle every 3 seconds. Now what does that mean? That means if it starts off here, it has to go to the extreme to the right, back to the middle, extreme to the left, and then back to the middle. That would be one cycle. Got it? Now the picture, if you were to describe the motion, now remember t equals 0 is when it's at the vertical. Okay? So t equals 0, it's right here. That suggests that it starts in the middle of the graph, which would mean perhaps a sine function. Notice, it takes 3 seconds. It goes all the way to the right, 12 inches to the right, back to the middle, then all the way to the left, 12 inches to the left, we'll call that negative 12, and then back to the middle. So I'm going to use a sine function only because the graph starts in the middle. The amplitude, or let's do the period first. It takes 3 seconds for the period, so remember that's 2 pi over b, so b would be 2 pi over 3 seconds. The amplitude is 12. Now, in this case, notice it starts up at 0 and it goes up, so the a would be positive 12. So the graph, here's the graph right here. 12 times the sine. I should say the equation d, distance from the center, is 12 sine 2 pi t over 3. Now how about this question? Find when the pendulum is 6 inches past the equilibrium position for the first time. So what does that mean? That means we start up here at t equals 0. Whoops. Start up here at t equals 0, and I want to know the time when it's 6 inches to the right for the first time. Notice it goes a total of 12 inches, so it's going to be some small positive number, right? Set the distance equal to 6, divide by 12, If you take the inverse sign, remember this is going to give you a number between negative pi over 2 and pi over 2. It's going to give you pi over 3, in fact, right? Isn't it? No, pi over 6, actually. Pi over 6. So you take pi over 6 and you multiply by the reciprocal, 3 over 2 pi. The time turns out to be 1/4 second. That's it. Here's an example where you have the water level in Puget Sound varies. The height of the tide from 8 to 16 feet, depending on the time. Now notice the high tide occurs at 5 a.m. Read that very carefully. The high tide occurs at 5 a.m. That's telling you the extreme point, right? So that suggests perhaps a cosine here. T is the hours since midnight. So at 5 a.m. would be the point 5, 16. Got it? So if you were to graph this, and I think that's the key here, is to graph the situation. If you can sketch the graph of it, I think you can find the equation. They're telling you the high is at 5 a.m. and it's 16 feet. And then it occurs again at 6 p.m. That would be 18 hour, right? T equal 18 hours? 16. So it looks like a cosine. Notice you have a vertical shift though. The way you find the vertical shift, remember how to find the vertical shift? You would take the average, I should say the midpoint of 16 and 8. The midpoint's 12. So we find the vertical shift by adding 8 plus 16 and dividing by 2. Then we can get the amplitude. Notice we're starting here at the extreme point. So A is going to be positive 4. If we were to start the minimum, A would be negative 4. Then the period is 13 hours. You can subtract 18 minus 5 and get 13. So that, and then you can find the phase shift. There is a phase shift. The phase shift is 5. So that's negative C over B. So if you want to solve for C using the method I like to use, C equals negative 5B. If you replace B with 2 pi over 13, you get negative 10 pi over 13. Putting it all together, you should get something like this. Now, of course, if you do the book's way, you would have 2/3 2 pi over 13t parentheses t minus 5 instead of that. There's 2 ways to write that, remember? Okay, let's do another one. Got time for a couple more here. This one, the outside temperature varies. It's sinusoidal. That tells you it's either a sine or cosine. The temperature varies from 47 to 63, and the average temperature first occurs at 10 a.m. That's the average temperature. Again, the secret is to just sketch the situation. They're telling you the average temperature, which would be 55. How did I find 55? Isn't it the midpoint between 47 and 63? That's how I got 55. So they're giving us this. This is given. So again, I think a sine is going to be appropriate here because you're given the middle of the curve. You're not given the extreme point. Of course, I imagine you could find these extreme points and use cosine if you wanted. But it seems more simple, more natural to use a sine here. Okay, so it's going to look like this. You first find the vertical shift. Remember, the vertical shift is if you take the average of 47 plus 63, you get 55. That's your vertical shift. The amplitude is measured from the vertical shift. So the amplitude, if you take 63 minus 55, you get 8, and that's going to be positive 8 because the graph goes up. The period is given to be, it says over a course of a day. That's 24 hours. So 24 is 2 pi over b. B is pi over 12. The phase shift is 10. So if you solve this, 10 is negative c over b. So c equals negative 10b. Negative 10 times pi over 12, I get negative 5 pi over 6. So this is your equation right here. Of course, it doesn't even ask you to find the equation. Let's go back and see what the actual question is. The question is, when does the temperature first reach 51 degrees? Okay, so in order to answer that question, we have to get the equation, even if it doesn't ask that, okay? Now that we have the equation, how do we find the time when it first reaches 51 degrees? Now notice, isn't that going to be, since midnight, it's going to be somewhere between midnight and 10 a.m. Somewhere here is where it's going to be 51, isn't it? So set the equation equal to 51. I'm kind of running out of space here. 51 degrees equals the function. I'm doing a couple steps here in my head. I subtract 55. So you get -4, and then you divide by 8. That's where I get the -1/2. You see, I subtract 55 from 51. That's -4. -4 divided by 8 is -1/2. Now to solve this equation, what I did then, like I said, I'm running out of space, I took the inverse sign of both sides. What's the inverse sign of -1/2? Inverse sign of -1/2 is -π/6. Okay, that's where this came from. This is the inverse sign of -1/2. And then, so if you solve this equation for t, I'll let you do that. If you solve this equation for t, you should get t equals 4 a.m. Here, Ferris wheel problem. You jump aboard a Ferris wheel, and the Ferris wheel is 1 foot above the ground. And at the highest point, you're 99 feet. So this is kind of how it looks. This picture right here. You see if I can zoom out a bit here. There. Maybe you can read this better. So the Ferris wheel is 1 foot above the ground, okay? So this will be the point 0, At t equals 0 seconds, you're right here. The highest you get is 99 feet high. That's the high point. And it takes 30 seconds to go around. So think of this as time. At time equal 15 seconds, you're up in the top. So what would the graph of this look like? At t equals 0, you're at 1 foot. And you're moving around this Ferris wheel. At t equal 30 seconds, you're also at 1 foot. So you're moving around in the counterclockwise sense. So at 15 seconds, you're at 99 feet. Got it? So what would you use? That's right. You'd use a cosine. The vertical shift, remember how to find the vertical shift? You would add 99 plus 91, take the midpoint of those. You add them up and divide by 2. So the vertical shift is 50. That's d. And then the amplitude is measured from your vertical shift. So the amplitude would be 49. I chose -49 for A because remember you're starting here. You're starting at the cosine, but you're starting at the bottom point, so it's negative. It's starting at the bottom of the cosine function. Period's 2 pi over b, which is 30 seconds. So I get b equals pi times t over 15. So there is no vertical, there is no phase shift because remember we're starting at the bottom of a cosine function. So this is what you should get for the equation. The last part of the question says, find the 2 times which you are exactly 90 feet above the ground. So if you think of the picture, I'm asking to find these 2 times when you're 90 feet above the ground. You just set the equation equal to 90. Now look at what happens when you solve for 90. When you solve for t, set the equation equal to 90, subtract 50, divide by 49, take the inverse cosine, and this is going to give you a number in the second quadrant, right? Because it's negative. But when you solve for t, you get about 12. I round a little bit here. You get about 12. That's the first time. Now, where would the second time be? This is the hard part. If from here to here is 12, from here to here is 12, right? Then what's this distance from here to here? Wouldn't that be about 3? I'm talking about the time now. If this is 12 seconds, this is about 3 seconds. So by symmetry, this other point looks like this distance equals this distance, so it would be 15 plus 3 seconds, and that's where you get 18 seconds for the other time. Okay, we'll see you next time. Bye-bye.